Welcome to our lecture online. Let's try to answer the question, what is gravity? A few hundred years ago, when Newton observed an apple falling from a tree, and he pondered what that really meant, why an apple would do that, and he looked in the skies and he saw the motion of the moon and the motion of the planets, he began to put the pieces of the puzzle together and he began to realize that gravity is a force between objects. And he was able to formulate an equation now known as the universal equation of gravity, which indicated that the force between objects was simply the product of the masses between the two objects divided by the distance squared times some constant known as the universal gravitational constant. But when Einstein came along, he challenged that thought. He said, gravity isn't really a force. What he claimed was, when you place an object in space, that space itself would bend. It would warp into the fourth dimension. And anything that comes close to that warp would simply fall into it. It didn't require any mass. In other words, light to come by, for example, if a photon of light were to come by, it would feel that bend in space and it would change direction. Not because light has mass, but simply because it would experience that warp, that bending in space. The larger the object, the greater the bend, and the more readily objects would fall into it. It would appear as if they're being attracted to this big object, but in essence, they're simply falling into the bend or the warp of space. And the greater the object, the larger the mass of the object, the bigger the bend of space, and the greater the force, or at least the apparent force, would be acting on the object. Objects would still simply be falling into that bend. This is why the Earth revolves around the Sun. The Sun causes a bend in space. The Earth, if it was standing still, would simply be falling into the bend, but because it has a velocity of about 30 kilometers per second, it stays in orbit, simply like a marble rolling around a hole like that without falling in. The Earth itself causes a warp in space as well, and the Moon revolves around the Earth because it is affected by that warp in space. And yes, even our bodies cause a warp in space. Now, our bodies are very small, and the warp in space is barely noticeable, but it is there, and with very, very fine instruments, you should be able to measure the change in an object nearby because of the attraction, the apparent force of gravity, which in essence is simply a warp in space around your body. And yes, even small objects as small as a ladybug do affect space to such a minute extent that it cannot really be measured, but we know that ladybugs as well cause a small bending in space, and if we could measure small amount of objects, we could see them falling into that bend. Of course, that would not be possible because it would be very difficult to measure. But there's no limit as to what objects can do to space, no matter how small they are. All objects in the universe bend space, and it's that bending of space that creates the sensation of the force of gravity. And that is gravity according to Einstein.